Hi friends, so today again we have gathered here just to complete the part of atomic packing factor over here. Now again this is related to the chapter number 1, that is the material science and metallurgy. The first chapter, structures of material. In that particular part, in the last lecture we have completed about or whatever the important stages in those particular part, that is the average number of atoms per unit cell. This particular part we have completed, and I think now you can be able to calculate the average number of atoms per unit cell for any structure, that is the simple cubic structure, FCC structure or hexagonal structure. So anything you can be able to calculate now. Now the next particular part after this, that is the average number of atoms per unit cell. After that particular part, the most important part, that is the atomic packing factor. So first of all, you just try to understand what is the atomic packing factor. The fractional amount of volume or space occupied by atoms in an unit cell is called as an atomic packing factor or atomic packing density or efficiency. So this is the volume of atoms in a unit cell, okay, or volume of the unit cell. It is related the term. So the fractional amount of volume or space occupied by the atoms in a unit cell. So first of all, we will just go with the concept of atomic packing factor for simple cubic structure. Now that APF for simple cubic structure, how it has been calculated. For that purpose, you just try to understand what is the geometry of this particular structure and what is the formula used to calculate the atomic packing factor for simple cubic structure. Okay, now this is the particular diagram, or we can say how the atoms are structured into the cube, that is the this particular diagram. Now the length of this particular cube is A, and this is the radius of one atom in this particular cubic structure. Now for a simple cubic packing factor, the number of atoms per unit cell is 1. So already this particular part we have covered into the last lecture, that is the number of atoms that we have calculated. So for simple cubic structure, the number of atoms per unit cell is 1. Now the side of the unit cell is of length 2r. So this is the radius of that particular atom and the length will be a. So here from this particular geometry we can be able to say that the a is equal to 2r. So the this particular two atoms are there of the radius r. So a is equal to 2r. Okay. Now how that APF is calculated? So this is the formula to calculate the APF. APF in the sense atomic packing factor. So just to calculate the APF, this is the formula, that is n atoms, that is the number of atoms per unit cell, then V atom in the sense volume of that particular atom, and V unit cell, that is nothing but the volume of unit cell. So this is the formula for APF, that is the number of atoms per unit cell into the volume of that particular atom divided by the volume of unit cell. So in this particular structure, already we have calculated the number of atoms per unit cell, that is 1. So this is we have covered in the previous lecture itself. Now what is the volume of atom? Imagine, or we can say this particular atom is nothing but the sphere. Okay, so when one sphere it is there, what is the formula of volume for any sphere? So formula for volume of sphere is 4 by 3 pi r cube. Okay, now unit cell volume that we have to calculate. Now unit cell volume, how it is calculated? So unit cell in the sense what? 1, 2, when we are connecting all those atoms, we can be able to form the unit cell. So here the volume of unit cell is nothing but the A into A into A, because just see, this is a cubic structure, so length into breadth into height, so all those sides are having the A, so A cube. Now A cube is the volume of this particular unit cell, A cube. So unit cell volume is A cube. So this A is nothing but the 2R. So here that particular term is replaced. So instead of A cube, we are putting the term A is equal to 2R. So this will be the formula, 1 into 4 by 3 pi R cube divided by 2R cube, that is A cube. So when we are simplifying all those terms, we are getting pi by 6. So it is nearby equal to 0.5236. This will be the formula for this. Now after completing the simple cubic structure, we will go with the next structure, that is the body centered cubic structure. Now for the body centered cubic structure, first of all, this particular part, again, how we have calculated the number of atoms per unit cell, that part we have covered into the previous lecture itself. Now in the primitive unit cell for the body centered cubic crystal structure contains the several fractional taken from the 9 atoms. So this part already we have covered. Now each corner atoms touches the center atoms. A line that is drawn from one corner of the cube through the center and to the other corners passes through the 4R, where R is the radius. Now this particular geometry here we can be able to clear that. Now what is the difference between cubic structure and body centered cubic structure? So in the center part of that particular structure contains one particular atom. Okay, so on the 4 corners, sorry, or we can say 8 corners, 8 atoms are there, like simple cube structure, but one more atom, it is concentrated at the center. That's why it is called as a body centered cubic structure. Now to calculate the APF, that is again the same formula, it is there, the N into atoms into V into atoms, that is divided by V into unit cell. Now the number of atoms for body centered cubic structure, it is 2. Already this term we have calculated in the previous lecture. Just to understand this thing, again you just refer the that I think 6th lecture. Okay, then again the volume of atom, it is again the same, 4 by 3 pi R cube, because again we are considering the volume of this particular sphere, that is 4 by 3 pi R cube. Now just to calculate the volume of unit cell. Now how the value of this A it is calculated, this I will explain into the next slide. Okay, now this is the geometry of body centered cubic structure. Okay, now just concentrate this particular geometry here. This is the sectional, or we can say cut section of that particular geometry. Now just concentrate on these particular edges. Now we have to calculate the volume. Okay, volume of unit cell, and unit cell in the sense that we are considering all those structures. Okay, this is the unit cell, and that's why from this particular corner D we will move, or we will consider the corner F. So we need to calculate the volume of from this particular D corner to the F corner. Now here these are the unit cells which is shown over here. Okay, these are the, or we can say that atoms. This is the unit cell and these are the atoms in that particular unit cell. Okay, now here just see, for this particular atom this is the radius R. Now this is the again the perimeter of this particular thing, that is the, that's why it is the 2R, and again from this to this it will be a R. Okay, so from D to F, this all particular length, it will be a R plus 2R plus R, that is nothing but the 4R. Okay, and D to C, C to G, G to F, this thing we have to travel. Now just see, just concentrate on this particular formula. When we want to go for the D to F, okay, so this will be a one triangle, D to F, and then here just see this G. So D to F is equal to D to G. First of all we have to move from D to G, and then G to F. So this is the right angle triangle. So here we can be able to use the Pythagoras theorem. Okay, so this will be a D to F is equal to nothing but the square of the one side, that is dg square plus gf square. So this is the Pythagoras theorem. Now dg, here dg, we will just concentrate on this particular length. Dg is equal to dc plus cg. So when we want to come towards this particular dg, this whole length, it is near about the addition of dc plus cg. So this is divided. So dg square is equal to dc square plus cg square, and df, that is d to f, that is 4r, 2r plus r. This is the 4r. So we are just replacing all those values. Df square, we are putting the value or that dg value from this particular equation, that is dc square plus cg square plus gf square. Okay, now df is nothing but the 4r, dc is equal to a. Okay, this is all having the length a plus cg is again a plus again gf, this will be a. So a square plus a square plus a square. So here we are getting, after calculating, a is equal to 4r divided by cube root of 3. Now you have got this 3a square is equal to 4r. From this, 3a square is equal to 4r square. So 3, here it is in the divided position, that is 4r square divided by 3 is equal to a square. So by taking the under root of this, we are getting a is equal to this particular value. Okay, now after clearing this a term, how you are getting, here we have to put the volume of unit cell, that is a cube. Okay, a into a volume of this, so that will be a cube, and value of a is 4r divided by square root of 3. So this will be a square root of 3, and here we have to make the a into a means a cube. So cube we have to take. Now by simplifying this particular term, we are getting atomic packing factor for BCC is 0.68. So I think it has been cleared now. Now next, that is atomic packing factor for FCC, that is face-centered cubic structure. Now to understand the face-centered cubic structure, here that structure it is there, face-centered cubic structure means on the faces that atoms are there. Now again it is same like BCC, R plus 2R plus R, but we have to just cover the edges from D to B itself, because on the face itself that structure it is there. On the faces that atoms are there, that's why we have to only consider the corner atoms. In the previous BCC, that centered cubic structure is there, that's why we have traveled from D to F just to cover that particular unit cell. Here just to cover the unit cell, only D to B we have to travel, and these are the structure it is there. So from this particular diagram, first of all we need to calculate the value of this A. Okay, what is the value of A or R? Anything you can be able to calculate over here. So here in the closely packed structure it is there, just to calculate the APF for this. Here first of all we need to calculate the volume, average number of atoms per unit cell. Already we have calculated in the previous lecture, that is the 4, okay, into 4 by 3 pi r cube divided by value of the unit cell, that is the A cube. So pi r cube, here we have put the value of r. Now how that r is calculated? So r is calculated from the previous structure itself. So db square is equal to dc square plus cb square. db square is equal to dc square plus cb square. That is again the Pythagoras theorem has been used over here. So dc square plus cb square. dc is a, cb is a, and db is 4r, 2r plus r means 4r. So here just 4r square db, value of db is 4r. The square of this particular term is equal to a square plus a square. So 2a square is equal to 4r square. Okay, means 4r into bracket square. So by simplifying this, we are getting the value of r. R is equal to a divided by 2 into under root of 2. So here we are just putting the value of r over here. So after putting the value and simplifying this particular terms, now you need to just take the calculator, the notebook, and just calculate this particular thing. That is, for the FCC, we are getting the value is 0.74. Okay, so I think this particular structure again it has been cleared. Now again I will just take the review of this particular terms. For the simple cubic structure, APF is 0.52. This questions might be asked in your examination. These questions are coming for your gate examinations. So what is the APF for simple cubic structure? In that case, you have to choose this option is 0.52 or 36. Again, you have to just consider those terms. Then for the BCC, the APF is 0.680. Again, for the university examination, this question might be there. What is the APF, or calculate the APF for BCC structure? Then the APF for FCC structure is 0.74. What is APF? Atomic packing factor. What is FCC? Face-centered cubic structure. Okay, so just try to understand these terms now. So this will be a 0.74. Now it is after this, it is very interesting part, that is hexagonally closed packed structure. So this is the HCP, we can say, or it is called as an HCP. For the HCP, one interesting term it is there. Again, the same formula we have used, and this particular task I am going to allocate you, that you have to calculate at your own now, because 3 structures we have covered. Some sort of that homework part, for the homework purpose you have to just calculate these things. Now again, the same formula is there. For the APF is equal to N into atoms into V, that is volume of atom, divided by volume of unit cell. So the number of atoms, that is 6. Again, this term we have taken from the last lecture itself. We have calculated already the number of atoms in the last lecture. Then volume of atom, it is 4 by 3 pi r cube. Similarly, like a sphere, because again the unit cell is nothing but the sphere we have considered. Now this is the very interesting part, how this particular volume has been calculated. Now this is your homework, you have to just work on it. Okay, because in the week you are getting the ample amount of time now, and you can be able to refer some books, and then you have to just do this particular homework, how this particular term has been calculated. Now we are just putting the values in the latter steps. Okay, so this will be a 3 into under root of 3. So value of A is nothing but the 2r. So just we are putting the term 2r over here. The value of C, that is the 4 into under square root of 2 upon 3 into r. So that particular term we have put it over here. And after this, we have to simplify the things. Again, for the HCP structure, we are getting the APF factor is 0.74, same like FCC structure. Okay, now this is your task. You have to calculate how this particular volume has been calculated for the hexagonally closed pack structure. So it is very interesting thing. I hope you have enjoyed this particular lecture. And now what is the atomic packing factor? You have just understood this thing very nicely. Again, I am telling you, atomic packing factor, the fractional amount of volume or space occupied by the atoms in a unit cell, is called as an atomic packing factor. So you just work on it. Again, how to calculate the atomic packing factor for the various structures, and it is now it is very interesting to calculate those things. Thank you very much.